Welcome in to another new AMP podcast. I'm your host, Ben Dubose, and I'm the news editor with the AMP Publications team. In that capacity, I create content for both Materials Performance Magazine, or MP, as well as for Coatings Pro Magazine. Both are member magazines of AMP, Association for Materials Protection and Performance. Today's episode is part of our MP interview series, and on today's sponsored show, we're talking with Jamie Hillary, Remote Monitoring Product Manager at Alexis, which is now part of the Lindsay Corporation. As an industrial technology solutions provider, Lindsay's products and services include remote monitoring, industrial data communication, mobile data acquisition, and wireless communication technologies, which can be deployed wherever high quality and reliability are essential. Jamie, thanks so much for taking the time to join us, and let's start off by introducing you to our audience. Can you give us a little bit of career background as far as your time in the industry and the path that's led you to today?
Sure, Ben. Thanks for hosting this and having me on here. I started with Alexis in 2005, right after Alexis had acquired a small remote monitoring company at that time called NTG for Network Technologies Group. And as I mentioned, we were pretty small. At that time, I was doing a little bit of everything. There were like 4 or 5 of us working in that part of the business. But we grew pretty substantially. And as we grew, I moved into sales for a few years and acquired a lot of knowledge from working with customers in the field about the industry and about the applications for our products. And then used that knowledge acquisition really to move more into product development, eventually becoming, I don't really like the term, but kind of the subject matter expert in Alexis for our remote monitoring and oil and gas pipeline in that part of the industry.
All right, and that's your background specifically. What about Lindsay as a company? And full disclosure, Lindsay acquired Alexis a few years ago, correct?
Correct. And Lindsay, for those who are unfamiliar, is one of the largest manufacturers of pivot irrigation systems in the world. Irrigation systems that go around in the field and create crop circles. And they bought us basically to do their electronics, their control systems in those pivots, as kind of with the rest of every industry. The agricultural industry has been moving into the digital realm with point-to-point communication, et cetera. They bought us to make their electronics and facilitate data communication between the agribusiness companies and their assets in the field, much like we do with oil and gas pipeline assets. So we continued with Lindsay to do essentially our core competency, which is getting data from point A to point B for the ease of the data consumer's use, much like we've done for 20 years or more in the pipeline industry. They really dovetail together very, very nicely. And that acquisition has been a real positive thing for Alexis in that, a lot of capital has been interjected into our facility. We have a larger engineering staff. A lot of benefits were derived by Alexis from that acquisition.
And as a follow-up to that, who are your typical clients or customers? What are some specific examples? I know you talked about pipelines, but just generally speaking, who are the clients or customers that you serve?
Well, from our Alexis portion of the Lindsay Corporation, it's really a kind of a who's who in oil and gas pipeline operations in North America and extending into South America, Mexico, in the Mideast. Transmission and distribution pipelines, with our primary focus being on cathodic protection monitoring on pipelines.
All right, so let's move into CP monitoring for pipelines and specifically the technology and how everything sort of works together. So when we're looking at the hardware and the software, as well as the design, the engineering, all of those considerations, how does everything fit together in terms of the offerings that you all have at Alexis and now Lindsay?
Sure. So starting with the field hardware, which is half the system and in many cases the most important part of the system, we design and build everything that we put out into the field here in our Olathe, Kansas facility, just outside of Kansas City. We have a complete in-house engineering department for firmware, hardware, and software engineering for our web portal, as well as a state-of-the-art electronics manufacturing facility, all housed under a single roof here in Olathe. So that gives us the ability to have a very good speed to market, as well as a great deal of control over every aspect of the field hardware that we supply to the industry.
Let's look at this through the perspective of user experience. How does data get from these units that are physically out in the field to the clients, to the customers?
Sure. So as I mentioned, we have a web portal. That's our primary access point for field users. So it's a secure website with multi-level logging capabilities. So a company can authorize some users to be what we call a company manager user, where they see and have access to all of the sites within the company. And then we have a CP technician capability, which they see and use and have full access to only those units or groups that they're assigned to. And then we have a read-only CP technician, which, like the name would imply, they can just consume the data. They can't directly interface with the units as far as doing rectifier interruption or changing configurations and such. The website, has the very common nowadays security keys, certificates, et cetera, to provide the essential data security for that's required by the industry. It's very easy to use and provides the user with the ability to pull units in the field, to send commands to units, to make changes to the configurations. We can load new firmware to units over the air if we want to implement new capabilities in units. And in fact, we pioneered the ability to configure the units all over the website rather than having to physically connect to a unit in the field and use a laptop computer or some other sort of computer interface to program a unit. So we're continually expanding the capabilities of not only the field hardware, but the web interface as well, to create a really turnkey, comprehensive solution for controlling, managing your cathodic protection systems.
You mentioned data security, which is always a concern, especially these days. How do you all convince your clients that their systems and their data are safe? I'm sure they have questions. I'm sure this comes up a lot when people are looking at your technologies, your solutions. How do you make the case that you have the right solution for data security? Is it demonstrations? What are you able to do to make customers feel confident that their data is in fact secure?
That's a good question. So what we do, there's several approaches that we take. First and foremost, we apply the security up front. So as I mentioned, we have all the conventional certificates that are continually updated to keep security current and to keep any discoveries of holes in the system closed by the companies that really are at the forefront of web data security. Our servers are housed, they were co-located in some Tier 4 data centers, and It's actually running on the Microsoft Azure cloud. So all of our data is cloud-based, but protected by all the Microsoft security. And then in addition, as I mentioned, we have controlled password access to keep unauthorized users from having any sort of access to our systems or to the customer's data. And we continually are testing our data security by, there's several companies out there that you can have actually try and penetrate your system and then give you reports. And we do that on a periodic basis. I think it's quarterly that we have basically penetration testing in order to assure that we are up to date with security. Then additionally, when we're working with customers, we inform them of all of our data security and of how they can best use our system in a secure manner as far as controlling their password access, controlling the access to different levels of users within their organization to make sure there's not a great risk for any bad actors to be able to access capabilities that could hinder their cathodic protection system.
I'm sure another question that you get involves the technology itself, because you all are using cellular and satellite technologies to transmit this data. So with how much those evolve on a regular basis, what happens when those change or sunset? What are you able to tell your customers happens in that type of scenario?
Yes, this is something that our industry and any industry using particularly the cell networks for data communications, we all face this typically about every 8 years or so with sunsetting of technologies. So we've been through this several times. Our original monitoring units back in 2005 and until about 2008 or 2009 were operating on the old analog mobile telephone system, the AMPS system. And then when that was sunset, we migrated to 2G. When we did that, it was a challenge for us. It was a challenge for us and for our customers and a lot of people in the industry. But one lesson we learned from that is kind of taking a look at our capabilities. And we made the determination very early on there that we're an electronics manufacturing company. There's no good reason why we shouldn't build and certify our own modems so we can control any future communication changes. So particularly as it relates to cellular communication, which is really the big challenge as far as maintaining your communication capability through technology changes. We now, every time that technology changes, we get early notice, as most providers of cellular communication do, of future changes in the sunset dates. And what we do is we then develop a modem for the new technology, develop it in-house, build it, test it. And then when it comes time for our customers to start changing their units to adopt the new technology, we can provide a drop-in modem instead of having to replace the whole system or buying third-party modems from other modem suppliers. We're able to supply a custom-built Alexis modem that's specifically with the pinouts and all the command sets and everything designed to work directly with our units. So that gives us a lot better transition program to offer to our customers than is widely seen in the data communication industry. As far as satellite technology goes, that's less frequent that you have changeover in that. But when it does occur, we are able to basically just accommodate the new technology via firmware in the unit. And then it's just a matter of connecting a new terminal to our existing serial port that we use for satellite communication. So that transition is also very easy. In addition to that, one thing we haven't really mentioned on several of our platforms, particularly rectifier monitoring platforms or any continually powered devices, we have SCADA capability through an alternative firmware that works via Modbus. So we are able to actually bypass in times when you need to the satellite or cellular communication and communicate directly into a customer's host system for their SCADA network.
All right, let's spin this forward as we wind down the podcast. We're talking now with Jamie Hillary, Remote Monitoring Product Manager at Alexis, now part of the Lindsay Corporation. So when we look to the future, I know there's no crystal ball, but in terms of future-proofing your technologies, where is Lindsay headed when it comes to the future of these communication monitoring technologies? What's on the horizon as you all see it?
Okay, yeah, there are several things we've been looking into. There are quite a few more localized type of communication technologies, LoRa, Wi-Fi. We've gone into some of that in some applications where we've needed to because of a customer's requirements. And we are currently exploring some of those for their capabilities for either enhancing our wide area communication or at least being able to concentrate multiple data sites in the field through a single wide area communication device. We've done some things similar to that with 900 megahertz radios, for instance, to provide local communication to multiple sites that then use one upload device. And that's pretty cool technology, allows us to branch out beyond just our core business of cathodic protection and corrosion systems monitoring to monitoring sensors and transducers that have no relationship whatsoever to cathodic protection. For instance, leak detection sensors. We're doing some toxic gas monitoring, and as well as tank level monitoring, pipeline temperature monitoring, things that fall outside of the cathodic protection or corrosion world, but benefit from that same report by exception technology that is key to our data reporting. And that's, we're taking measurements in the field at a very frequent basis, but only transmitting that data either on a periodic schedule or when data slips into an alarm condition. So we provide immediate notification when there's a issue that needs to be addressed right away, but we don't send just normal data continually, which allows our data communication costs to be very low. So expanding that type of communication technology into many other areas beyond just cathodic protection monitoring is one of the things we've really focused on over the last couple of years. Regarding future-proofing, the main future-proofing that we rely on still and will serve us well in coming years is our ability to quickly adapt to any new technologies regarding the communication, because we are able to actually design and build the communication system here in-house, be it a modem, a satellite terminal, etc. We're able to control all of that due to our ability to design, engineer, and build electronic systems.
And before we wrap up, one question that I love to ask all of our guests is about the feedback they get from clients. We've touched on this at parts throughout this podcast, but in terms of questions you get, feedback from clients, are there any general themes when it comes to the questions, the pain points, the concerns that you're hearing from people who are actually installing and using these out in the field?
Yes, there's several. One of the first ones that comes up often is how reliable are these systems in the field due to the harsh environments encountered by electronic equipment being installed, for instance, at rectifier sites with line surges and lightning strikes on pipelines in the near vicinity of rectifiers, et cetera. That's been kind of the bane of our industry for a long time. And through that, again, I'll kind of credit our in-house engineering and electronic design capabilities. Through the years, we've been able to look at damaged units, and we've undergone continuous improvement since the very early days, 2005, 2006, when I first started with them, to where we would kind of triage anything we'd see that came in damaged or destroyed. And from that, we've been able through generations of product to build what I think, as I mentioned earlier, our Scout rectifier monitoring systems. They are nearly impervious to line level surges and pipeline lightning strikes. So we get a very, very low percentage of units ever experiencing that. And typically when they do, whatever surge has damaged our unit has typically taken out the rectifier as well. So we feel like that's been handled pretty well. And that is one of the main questions customers ask. A couple of the others are, how do they use the data? Let me see the web interface. And we have pretty good demo program that we work with where we'll work with customers that are considering using our units. We'll put a unit out on their system with them and then use that unit to kind of go through a web-based training on, how to use the website, how to set people up in it, how to pull units, how to configure units, all of that. And that question about ease of use of the website is one of the key things, really. So those are kind of the two, the survivability of the units in the field and the ease of use of the web interface are probably what I would say are two of the most important questions that we're asked and that we answer for our customers.
Jamie, for anyone that wants to learn more or hear from you, how can they do that? What's the best way for listeners to learn more or get in touch?
Okay, so if you go to www.lindsay.com and then click on the Alexis page on that or the Alexis section, there's web pages for our monitoring devices, some downloadable documentation, other information, as well as a link to be able to contact our sales team directly. So, that's probably the best way. Or visit us at almost any of the short courses, area conferences, and particularly at the AMPP annual conference held next March, I think it is in
Nashville. Yes.
Yeah, Nashville. We'll be there. We're at really all of the major events. Look for the Lindsay booth. That's, we're transitioning now from using Alexis to Lindsay. Our trade name for the industry, Watchdog, is still going to carry over. So instead of Alexis Watchdog, it will be Lindsay Watchdog. But we're the same company we've been since I started with them in 2005. And we'll continue to offer the same high-quality field equipment and best-in-class user interface for years to come. So we look forward to hearing from anybody who's interested.
Folks, that is Jamie Hillery of Lindsay. And again, you can learn more about Lindsay and its products, resources, and services at lindsay.com, LINDSAY. Jamie, thanks so much for taking the time.
Thank you, Ben.
Absolutely. And with that, we'll bring this sponsored episode to a close. On behalf of AMP, I'm Ben Dubose. And if you want more resources from AMP or Materials Performance Magazine or Coatings Pro Magazine, just visit amp.org, ampp.org, or materialsperformance.com or coatingspromag.com. As always, thanks for listening, and we'll be back soon with another new episode.